Hey, how's everybody doing? Today we begin Unit 5, Analytical Applications of the Derivative. So we're stepping away from some of those real world context problems, and now we're looking at, hey, what kind of advanced algebra and more calculus can I do with them? For my Block 3 friends, sorry I was so late today. Zoom did not like me, would not share my screen at all, which was not a good thing. So today we will analyze functions by looking for critical points. This unit is one that every lesson builds on the previous lesson. You have to do lesson 1 first, then lesson 2, then lesson 3, then lesson 4. Everything that we learn, we just add another step onto it. So this is just the very beginning. And as we go through this unit, we'll continue to do some more things. So given the graph of x cubed minus 6x squared plus 9x, create a possible graph for f prime of x. Well, let's look at some important things. Over here, remember the prime is the derivative and that's the slope. Over here, the slope is positive. Right here, I have a horizontal tangent line, so the slope is 0. Then my slope is negative, it goes downhill. Down here, I have a slope of 0. And then my slope is positive again. So if I come over, that factors, we could do that, but we won't. Let's call this 1. And 1, 2, 3, this is 3. So between negative infinity and 1, I have a positive slope, which means it has to be above the x-axis. Positive, 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 positive. And let's label your graphs. When you're on the AP exam, you want to make sure your graphs are labeled so you know which is which. And then between 1 and 3, I have a negative slope. So that means it's going to dip below the x-axis. So over here, it's negative. And then to the right, it's going to be above the x-axis again. So positive, positive, positive. So I go from this cubic function to this quadratic function. It's a parabola. Now, I didn't actually find the derivative yet, but we could. The derivative is 3x squared minus 12x plus 9. Well, it's a 3x squared term, so I know it's a parabola. It's positive, so I know it opens up. Yeah, that's what I have going on. And in fact, just because we can, if I take this one step further, factor out a 3 and set it equal to 0, your Algebra 2 teacher would be proud. Good grief. You can tell technology was not my friend today. This factors into x minus 1 and x minus 3. So x equals 1 and 3 are the solutions. They are the roots here and here. And in fact, I think you even in pre-calculus made some number lines and told me when a function was above or below the y-axis. We're going to do a little bit more of that today. I have to take a break here for a few minutes, but I'll be back. All right, so we are looking at derivatives and increasing and decreasing. So maximums and minimums are called extreme values or extrema. Optimization is the process of finding these extrema. Remember, we don't always have an absolute maximum or minimum. So I have a theorem for you. If f of x is continuous on a closed interval from a to b, then f of x takes on a maximum and minimum value on that interval. So that's where I'm looking at absolute maximum and minimum. Critical points. You're going to be tired of me saying that phrase. Critical points occur where f prime of x equals 0 or where it does not exist. So as a reminder, your derivative is the slope. So this is where the slope is equal to 0. This is where my derivative does not exist. You might have a cusp or a corner. You might have a vertical asymptote. We were just talking about this earlier today, that a critical value would occur at an asymptote, but it's not actually a point in the domain. So that word point, maybe not so much. I've done a little bit of reading on this, and different textbooks define them differently. So you just gotta be aware of your source. So let's look at this graph that we have. Where are the endpoints on this particular graph? Well, the endpoints occur at A and at E. My local extrema are any local mountain tops or valleys. So I have a local max at B, and I have a local max at D. I have a local min at C. My absolute max, where's the highest of the high point? that happens up here at B. And my absolute min, I think, did I just say local max? I meant absolute max. I don't know, I'll have to rewind. Your absolute max is the highest of the high, and your absolute min is the lowest of the low. Now, in this case, the endpoint does count. The endpoint does count. I was on a nerdy calculus teacher Facebook group yesterday, and they said, hey, do endpoints count as local max or min? And the response was from the guy who's doing the AP calculus videos and is really, really knowledgeable about the AP exam and everything, said it just depends on the text. It depends on how your textbook defines it. Some books out there will say that the endpoint can be local max or min, and some will say no, that it can't be. So just kind of be careful around your endpoints. For our purposes, I always think of local max and min as mountaintops and valleys. So there you go. Find the extrema for the given graph. So your local minimums, where are there any low points? I'm going to go with 1 on this graph. Local max, how high can you go? I'm going to see a local max over here at 0 and one over here at 2. My absolute min, what's the lowest point on the graph? Well, 4. I see an open circle there, but it's almost to 4. And your absolute max, how high, or the x value where that happens, is at 2. So sometimes ordered pairs are nice. Just be careful on what they're asking for. If they want the x coordinate, you would write the x value. If they want the value, they want the y value. So what's the maximum value? They want the y value. What's the minimum value? They want the y value. So I'm going with x's on these. I should mean space for that. So what does this look like for you? Find the critical points of the following function. So f of x equals 9 minus x squared. F of x equals x cubed minus 9x squared plus 24x minus 10. The critical points happen with the first derivative. All right, sorry, scene change. There was second grade gym class happening in the other room. So example 2, f of x is x cubed minus 9x squared plus 24x minus 10. So to find the critical points, you want the first derivative. 3x squared minus 18x plus 24. You want to set that first derivative equal to 0 because the critical point happens when the first derivative equals 0. And then your job is to solve for x. So I'm going to factor out the 3's. I've got x squared minus 6x plus 8. And then I'm going to factor x minus 2, x minus 4. So my solutions are 2 and 4. Those are the critical points. I've got iPads going on everywhere. We're watching YouTube here at our house today. Okay, so good. Find the extrema. Look for the max and the mins. Well, the extrema are going to happen at the critical points. That's a place to start. So start with a critical point. F prime of x is 6x squared minus 30x plus 24. I'm going to set this equal to 0 and factor out a 6. And then this factors to x minus 1 and x minus 4. So x is equal to 1 and 4. Now, on the previous problem, these were critical points. On example 3, I want to know which is the max and which is the min. We're going to have 2 other ways to solve this later. But for what I would like you to do right now is find f of 1 and find f of 4. For now, that'll tell you which one is higher and which one is lower. So if I put a 1 in for x, I've got negative 13 plus 24 is 11 plus 7, 18. I hope my math is right. And f of 4, oh goodness, I can't do that on my own. I'll be right back. All right, I'm back. I got my trusty calculator. I got a negative 9. So my extrema means 118. Remember, that's really an ordered pair. This is my local max because it's higher, it has a higher y value, and this is my local min. And if it makes you feel better as ordered pairs because that's what you're used to, you can call it 118. I'm good with that. You can call it 4, negative 9. Just be careful on what the problem's asking for. Example 4, find the absolute maximum of this function on the interval from -1 to 2. Now we talked about relative max and min, and there's absolute max and min. So relative max and min, you want to know, where is it going up and down and all those other things. Absolute max and min, you need those y values. So I need to find the critical points. So I'm going to say I need the derivative. So f prime of x is equal to 0 minus 2/3 x minus 1 to the negative 1/3. By chain rule, I'd multiply by 1. So if I clean this up a little bit, negative 2/3 x minus 1 to the negative 1/3, negative 2/3 over x minus 1 to the 1/3. Now I have to set this equal to 0. So something interesting happens here. If I multiply both sides by the denominator, or cross multiply, if you think of it that way, 0 equals -2. But 0 does not equal -2, so this is no solution. There is no place that I have a horizontal line, but I do want to see if there's any place where it's undefined. So I need to set 0 equal to the denominator as well. So I'm going to divide both sides by 3. Then I'm going to raise both sides to the 3rd power. So 0 cubed is still 0, equals x minus 1. So x is equal to 1. Now, Mrs. Oakes and I were chatting about this. Is this a critical point, yes or no? If you're looking up some other videos out there, they might say, no, it's not a critical point because it's not part of the domain. But if it's divided by 0 in the denominator, but it could be a critical value that's going to happen at vertical asymptotes. You could have a critical value where you still have to look for a sign change. So let's see what's going on here. You want to find absolute maximum. So you need to check your endpoints. You have to check the y values at -1, the y value at 2. And if you got a critical point, we're going to graph this in a minute. If I recall, something special happens there. You want to take -1 and 1 and 2 and put them into the original problem to see what numbers you get. If I put in +1, I get a +1. If I put in a 2, 2 minus 1 is 1, 1 to the 2/3 is 1, 1 minus 1 is 0. And if I put in a -1, that's a -2 to the 2/3, that's going to be a crazy decimal. Oops, I didn't do that right. Yes, I did.
The dogs in here. They're ruining my gym.
Okay, bud. All right, the dogs are out of gym class now. So now I have y values for those specific pieces. So f of 1 equals 1 is the highest y value. So there's your absolute max. And then f of 2, nope, equals 0. It's not the lowest. -1, -0.58 is your absolute min. Okay. So before we leave, I want to see what this looks like. 1 minus x minus 1 to the 2/3. 1. Hopefully I don't forget what it is. Y equals 1 minus x minus 1 to the 2/3. There we go. So when you look at this, what's going on at 1? Yeah, that's the absolute maximum, and our interval was -1 to 2, right? Unfortunately, I can't draw on the screen, but there's -1 to 2. Up here at 1 is our maximum. But the derivative didn't exist there. We had to divide by 0 on the derivative. It's a critical point where I have a cusp. So I don't have a horizontal tangent line. I don't have a slope of 0. It kind of feels like it should be a slope of 0, but it's not a nice gradual change. It goes from a positive slope to a negative slope, abruptly. That's what causes that cusp there. But it is the absolute maximum on this graph. So I just want you to be able to see what's going on with those. So for absolute max and min, you definitely need to check those y values. All right, folks, I think that's all I've got for you. When it comes to extrema, this is kind of a little extra or looking ahead. I want to go back to example 3. This is looking ahead. This was a short video, so may as well. So example 3, we're going to look at again. 2x cubed minus 15x squared. 3. F of x equals 2x cubed minus 15x squared plus 24x plus 7. Okay, so another way to find those extrema, and again, this is just looking ahead instead of those y values. I want you to have another option. Find the derivative. We have 6x squared minus 30x plus 24. To find the critical points, we set that equal to 0. And just like we did above, factor out a 6. And then you're going to factor that binomial that's left. So I've got x minus 1 and x minus 4. So x equals 1 and x equals 4 are the critical points. Great, we did that. And then we found the y values a second ago. We can talk about increasing and decreasing. So again, this is looking ahead. The first derivative tells you about slope. If I make myself a number line with the 1 and the 4, and I evaluate at the derivative, I need to put in 0. I'm going to think of a number 0. I'm going to put 0 into the first derivative. You can use this version. I kind of like the factored version. I think it makes the mental math a little bit easier. So 0 minus 1 is a negative, and a 0 minus 4 is negative. And negative times a negative makes positive. If I try the number 2, because that's between 1 and 4 here, 2 would give me a positive, 2 would give me a negative. So this is a negative. If I try the number 4, this gives me a positive, or bigger than 4, I need to try 5. A positive and a positive is a positive. Where I switch from going uphill to downhill means x equals 1 is a maximum. Equals 1. Get rid of this in here. If I switch from going downhill, negative slope, to uphill with a positive slope, that's minimum. There you go. So we will talk about that more, that switch from decreasing to increasing and increasing to decreasing. But I just wanted you to have a head start on that. So there you go. Good job. Keep up the good work. Sorry I'm super late today.